How to graph y equals 2 to the x. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. Y equals 2 to the x. So start with a grid. We encourage you to make a table. And these are the 7 values that we would like to try to start. So 2 to the third power, 2 times 2 times 2 is 8. And we ask you to pause the video and complete the table. So we did the positive ones, and then did 2 to the negative first power, which is really the reciprocal of 2, which is 1/2. 2 to the negative 2 is 1 over 2 to the positive 2, which is 1/4. And 2 to the negative third is 1 over 2 cubed, which is 1 over 8. So let's go ahead and plot these 7 points. 3, 8, 2, 4, 1, 2. The y-intercept is at 0, 1. And then these 3 are getting smaller and smaller and smaller. Connecting the points look like this. But we'd like to look at the end behavior, what's happening at the ends of the graphs, here and here. So as x gets very, very large, what's happening to the y values? For example, if x was 1,000, then 2 to the 1,000th power is just out of sight large. So that would mean the graph would be going up very, very quickly right here. Y is getting very large quickly. And as x gets very small, but in the negative direction, out here somewhere, for example, if x is negative 1,000, then what's happening to y? Well, 2 to the negative 1,000th, by definition, would be 1 over 2 to the positive 1,000th power. 1 over a huge positive number is a number really close to 0, but it will be positive. It will be positive. And how we show that on the graph is out here. Kind of flattens out. This makes the x-axis, the line y equals 0, a horizontal boundary line, which we call an asymptote. And it would look like this. The line y equals 0. Usually we draw it dotted or dashed, which means the curve gets really close to it without touching it. Some terminology. We do have a y-intercept at 0, 1. The horizontal asymptote in this case is the line y equals 0, or the x-axis. So what does the y to the 2 to the x dance look like? Well, again, we'd start off with the y-intercept. Would be a good place to start. And then from the origin, we go right 1 and up 2, because 2 to the first power is 2. Right 2 and up 4, because 2 squared is 4. And right 3 and up 8, because 2 to the third power is 8. If we go to the left 1, it's going to be up 2 to the 1/2, because 2 to the negative 1 is 1 over 2, which is 1/2. Left 2 up 1/4, 2 to the negative 2 is 1/4, 1 over 2 squared. And left 3 and up 1/8, 2 to the negative third, 1 over 2 to the positive third, which is 1 over 8. Connecting the points, and we get this beautiful looking 2 to the x curve. A graph that's shaped like this is an example of exponential growth. And as x gets larger, y gets larger really, really fast out here. Exponential growth. Domain and range. All right, so we have the graph in the table here. So you can see that the domain, pretty much all the real numbers along here have a point above it. So the domain seems to be all real numbers, script R. The range is not all real numbers. Notice that 0 is not included, but everything above it has a point either to the left or the right of it. So the range is all positive real numbers, not including 0. And we write that as the set of all y such that y is a member of the real numbers, y is strictly greater than 0. Note 0 again is not included because the x-axis is an asymptote. Where can you see this curve in the world? Well, here was an example we found online. We invite you to interact with the graph of y equals 1/2 to the x video in this series. That would be a natural one to follow with this.